Hi, I guess it's welcome to the Willoughby Wallace Memorial Library. My name is Thea. I am the self-proclaimed archivist of the library, and I just love history, so I was excited about this program. I talked to Sara last summer maybe about the dome, and I just thought it was fantastic. So your presenters tonight are Sara Kirschenbaum and Jeremy Zieman, then Posel and Shea. And I am recording the event, so you all know if you come up here, you will be recorded. All right, enjoy. Go ahead, Sara.
Well, hello, everyone. I feel like tonight is very triumphant. There's a lot of individuals that have made my dad's dream come true. A lot of them are in this room, so I'm looking forward to telling you a little bit about the story about how the dome came to be. My name again is Sara Kirschenbaum. My father designed the dome. My mother commissioned him to design the dome. And I kind of feel like the dome and I grew up at the same time. So I'll tell you a little bit about our story. What we're going to do, just so you know, I'm going to give a little introduction, and then we're each going to introduce ourselves for 2 minutes. And then we're going to structure most of the talk while we're going through some slides. So you'll be seeing lots of pictures, and we'll wrap up with question and answers. And I do have a few little show and tell pieces over there on the note table. So this story starts 98 years ago when my grandmother and grandfather got married, Leonard and Grace Weil, and they kind of couch surfed for a year after they got married, and then they really felt like they needed it was time for them to settle down. They were getting that message from the people they were crashing at their houses. And they heard that there was some islands off the coast of Connecticut. And they rode into, I think it was Branford, and they saw a realtor who was dozing in a chair in his underwear. And they went up to him and they said, "Do you have any islands for sale?" And he said, "Yes, I do. Come back tomorrow." So they came back and he took them in a lobster boat with Addison Bradley to captain the boat. And they went out to Outer Island and they immediately fell in love with the island. And they went in the house. There was one big house, but there were storm shutters on. They didn't even bother to take those off. They couldn't really see the house, but they fell in love with the island. And they, on the way back in the lobster boat, they said, "Okay, how much is it? We really want it." And they gave them the figure of how much it was. And they're like, "Oh, dream, this is perfect, but we can't afford it." So they offered half the price, and eventually that was accepted. And so Leonard and Grace moved out to Outer Island in the months of the year that they could be out there, and they started a family. And Judith Shea is with us here. She's one of the children of the family. She's in the back of the room. And my mother is another child of the family. And my mom used to, my mom's not much of a rebellion, but the way she rebelled against her family is she would sneak out of the island, which is hard to do, in a rowboat, and she would go into town and listen to the Stony Creek drum corps practice. That was her big rebellion. And eventually she went to art school in Paris, and then in North Carolina at Black Mountain College, and she got to hear Buckminster Fuller speak. Now, simultaneously, my dad was in another college, Institute of Design in Chicago, and he also got to hear Buckminster Fuller speak. And he became kind of a protege of Buckminster Fuller and began designing domes. My father was in the Second World War, and he really wanted to use domes to change the world, to make affordable, light housing mass-produced for people, so everybody could afford a beautifully designed home. But the only interest he got in his dome designing business, it was called Domax, and it was, no, sorry, it was called
Geodesic.
Geodesic, thank you, Domax was another company. The big client they got when they were offering domes was the Department of Defense, and my dad designed 31 radar domes to be placed around the North Pole to have a warning if the Soviets were sending nuclear missiles over the North Pole. So he did that commission, but in his heart, what he didn't like war, didn't want to work for the Department of Defense. He really wanted to make affordable housing for people. And around that time, he got a call from Susan Weil, maybe going by Susan Weil Rauschenberg at that time. And she said, I'm looking to have a dome designed for a studio in the woods in Stony Creek. And he was overjoyed to have an opportunity to make his vision become a reality. The only thing was, his vision was a little different than what his client asked for. What his client, my mother, asked for was a studio in the woods. And he began working on the project, and slowly it morphed into a prototype single-family home dome. And in the meantime, they fell in love, they got married, they had me. Some changes had to happen in the design of the dome so I could have a room. So the dome was doing pretty well. My father was brilliant and did things so ahead of his time, so beyond. I mean, if you think about designing a dome without a calculator, much less a computer, I mean, how do you do that? But eventually his focus shifted, and he began doing sculpture instead of architecture. And the dome languished. It was unfinished for years until these three gentlemen up here stepped in at the behest of my mother, who really wanted to see the dome completed so my father could see it and feel good that project was finally completed. So who we have up here is Joseph Shea over there on the edge. My mother hired him as general contractor to restore the dome. And then the next hired was Ben Posel, who was and is the architect for the project. And then Jeremy Zieman showed up with the patience of a saint and a sense of perfection that really matched my father's. And so I'm going to step back a little bit here and let these three gentlemen introduce themselves. I do want to pause for a second, and I should have said this initially, and thank Thea Reitzman for having us here. She heard about the project last summer and really has helped us move the project forward. And one of the things she did is she got us in touch with John Herzand, who's here, who helped us get a restoration award, and we're very proud of that. Yeah, why don't the three of you take a couple minutes to introduce yourselves, then I'll walk us through the slideshow and we'll just sort of chime in.
Hi, all. Good evening. I'm Ben Posel, the architect for this team. And thank you, Sarah, for that great context and intro. And thank you all for your interest here tonight. I would just say for me, this dome is part elegant house. It's part amazing art project. and it's part manifesto. And by that, I mean, it's a built example of a set of ideas that were brewing post-war and in the mid-20th century. And these ideas, I think many of them still resonate today and have some relevance today. And one group of those ideas has to do with using novel geometries to design very lightweight structures that could be a kind of kit of parts that could be manufactured en masse in a factory at very low cost to produce affordable, efficient, beautiful housing. And this system, of which this is an example, creates very light, easily transportable pieces, assemblable by a small crew with hand tools. So there's some magic to that. And the last thing I'll add before I flip it over here is that this dome has had many lives, and in each chapter, not 9 lives, but quite a few, in each chapter, there's these thought-provoking questions that it provides. So much to think about, from the theoretical, like how do we shape space and how does space shape us, but also very pragmatic that we all had to wrestle with in this strange geometry to make it really function and work. So I hope maybe some of those questions will come up in the slides in our discussion tonight, and we can share those with you and touch on a few of them together. That's it for now, and I'll flip it over to one of you guys.
I don't know if the mic is live.
Okay, hello, maybe not, maybe just part of it.
It's a small.
I'm Jeremy Zieman. Before my introduction to the dome, I had about 20 years under my belt of fabricating and assisting others with passion projects. I'm a sculptor myself, and had often been influenced by using multiple materials: plastics, wood, fiberglass, steel, and as an artist was often influenced by some of the 70s artworks that were being done with art and technology. When I was introduced to the dome, it was done so by the man over there, Shea, and we were in somewhat concentric circles in the local area, and I knew him as a top-notch contractor. And I was told that there was this dome project he had, and I thought, oh, it's going to be one of these plywood things in the woods that I've seen before. That's probably not going to be that interesting. One point we finally connected, and I thought, well, this will be an opportunity to see it, get a cup of coffee, call it a day. And I was immediately awestruck with what I saw the first day with Joseph. And one thing I learned is becoming a part of this team that Joseph created is he was just sort of feeling things out to assemble. And even tonight, when we spoke earlier, he was talking about his passion for racing, and he has this sense of team effort and use of technology, and how that is incorporated into racing. And he really sort of put this together. He had a lot to lose because not only is he a great contractor, took on a super complicated project, but he was doing it with family. So there was no opportunity for failure. So for me, seeing what Bernie had already created and what was there was very much in line with prototypes and sculptural projects that I've done for others that don't really meet the criteria of houses that Joseph was building, where, you know, there's a gabled roof, there's an entrance, there's standards. This thing was more sculptural, more futuristic, but also just there was so many elements together that as I was looking through, I thought I would do this differently, might do this differently, and it really merged a lot of my personal interest with interfaces of materials. So part of this team, working with someone like Ben, who not only has a functioning architectural practice and a professor. He has the family history too. So he was a real connection to Bernie for a very early age. So the team element here of Ben and Joseph, myself, and then the access to Joseph's team of I guess you can call them subs in this world, but I find when I do projects for others, I used to do a lot of projects for Saw Lit, and I would work with people that work with common concrete block, and they have this expectation of getting a certain amount done in a day. And they drop their tools and they want to feel like they're making progress. And when you engage someone like that and get further into a process, they really take a deeper connection to it. So I felt like everyone that's been a part of this really got a deeper connection. So I think we'll learn more when photos come.
Yeah.
Thank you, Jeremy. I'd like to introduce myself. I'm Joseph Shea, a building contractor. But I'm gonna kind of do, I'm gonna ask you all a question. How many of you went to Expo 67? Okay. I was 14 years old when I went to Expo 67. And never in a million years, well, let's go 44 years ago, I met my wife Judith. A dome in the woods. So I heard about the dome for many years. And then around 2006, Susan reached out and said, can you take a look at the dome? It needs some work. And when we get to the slideshow, which we're going to get, you won't believe what we had and where we are now. And what I'm like to say about this whole project is I could have never imagined going to Expo 67 and then actually getting to work on a dome that is this unique. And I'm gonna probably swipe a bit of thunder here, but it's a cantilever dome, which means that a portion of it is unsupported. And it's an incredible concept. Bernie figured out how to do this. And when I first saw it, I was really taken by the engineering that went into it. And as Sarah mentioned, this was way back, 1958 is when he started this. And so I'm pretty honored to have been part of this project. And I do want to add one thing. Someone once commented and said, Joseph, you're kind of like a force multiplier. And I love that. And one of the things that I love doing is working with talented people and eking out as much as possible to get it done. And this is an example of that. Thank you.
Okay, so you've gotten to meet 3, 4, 5 heroes of the dome, and I think it's important to do a special shout out to my mom because she commissioned the dome. She put up with summers and weekends of working on the dome as our family was raising, and then she assembled this team to restore it for my dad. So shout out to my mother, Susan Weil. You can look her up online. She's a wonderful painter, and she would have been with us today, but she was busy painting in her studio in Brooklyn. Okay, so let's start on the slideshow. There's the donut. Is that as bright as we can get it? Should turn more lights out?
Turn the lights out.
Yeah. Okay. So this is a picture I took a couple of years ago. There's another one, and maybe I'll let you jump in here then. This is a good time.
Sure. We could, any of us could jump in here. I think we have a handy little laser. Here's that cantilever Joseph was talking about. It's a little hard to see here, but the dome is floating above the ground from a stem closer to the center, floating over this Stony Creek granite. And One thing I'll just mention in this photo is notice how thin all those struts are and how carefully engineered and careful the fit is. This is nothing like a mid-70s shingled or wrapped structure that Jeremy had alluded to. I don't know if you guys know that.
Before you continue, could you explain what a cantilever is?
Yes, Mr. Cantilever?
Okay. You know when you've done an old fashioned diving board,
Sure.
if you walk all the way out to the end of the board, you're like cantilever because it's being held up behind you. So underneath, this is about 7 feet. And so the structure is all buried on the outer edge, and then there are beams at each one of these points.
It's like a mushroom with a stem.
I see.
It sticks out.
And so cantilever means supported only on one end, not held up on two ends like a
Yeah.
posts and beam. So
Thank
it's
you.
just held on one end and going out into space.
And what was the reason for cantilevering, just to keep it off the ground?
Well, I think there were multiple reasons, but one that you maybe see in other shots is it gives a feeling of flotation and lightness
Oh.
and allows also a little more connection with the land, which was an important aspect for Bernie, the flow of inside and outside modernist vision where the land actually flows underneath the structure.
Let's step back in time a little bit and see how this was constructed. Here's a photograph that was printed in August 58.
Yeah, right, the original foundation pour in 1958. So the perimeter of the dome itself, though, goes out to here
Oh.
and to here. That's the footprint of the structure that is sort of the envelope or the wrapper of the house is much bigger than this. This is sort of the stem of the mushroom underneath it.
I think also from a sculptural perspective, when you think of the cantilever, I think big center exercise fought with a base.
Yes.
And there's this idea of how this work that's unique gets planted. And somehow the cantilever it's more recessed, it's hidden, and the dome becomes more accentuated in that way. So I think it was a great approach. Someone just sent me a picture the other day of the sculpture in front of the Louvre, and they made this gray plywood box to set it on, because they want people to kick it. And
Right.
it's like, there we are back to this ugly base.
Yeah. Pedestal is important, yeah.
So I can kind of jump.
Yeah,
over
speak to that.
These beams right here, this is the foundation. This continues out another 7 feet. That's the cantilever part. And then this is actually pretty sophisticated. That's a 4x10 fir stick that's one piece all the way back. And then Bernie boxed it in on either side with another 2x10 to create a built-up beam. So during our development of the dome, we brought in a structural engineer to analyze all of the things that Bernie did, which was basically done pre-engineered. And we had to make sure that all the numbers worked out. So,
You want to point out my dad there, Ben, with the pointer?
I can make it right now.
Yeah, there's Sam.
Yep, there's a young Bernie in 58. Okay, what happened? Yeah. So this is a nice example of the start of going up with the geodesic triangulated facets, the forms beginning to rise up off of the base. And you can see how light and short each piece is, but they are gonna interlock to create this very strong, stiff, yet light shell.
What are those strips made out of?
You guys want to speak to that?
what's that?
What are they made of? What's the material?
The strut bars are aluminum extrusion. I think they're like 61 alloy, then the hubs are casting. And in the renovation of the project, we had to reverse engineer the cap rails, which were that same as the bars are, and the company in Connecticut in New Haven actually made the dye for us and produced those parts.
We'll see a little cross-sectional drawing that Bernie made of one of these struts. It'll be a little cross-section cutting through one.
Pictures of the original.
Yeah, these are original.
This was the original build, yeah.
So what's kind of fun, see the box? He's taking the struts out of the box.
So this whole house came in little boxes. They're not even using power tools. Yeah.
This goes to the origin of the idea of it being a kit. Here he is basically taking a piece out of the box and putting it into the hub.
One of the reasons I like this picture is my dad wasn't shy about having us kids work on all kinds of things. So that's my brother there who's helping build it.
Yeah, people keep it going. All right, getting close to the apex and an all aluminum frame. Aluminum struts and hubs all fitting together with that close tolerance.
That's my brother.
So that's before any glass went into that area. Chris is flopped in there and remarkable how strong this thing is for its weight.
That's a cross section of one of the extrusion bars or strut bars.
Oh, yes, take it on the it's this top.
That cedar channel. There's a cap rail that's flat that interlocks into that center channel. And on left and right sides of that was the capturing of whether it was glass or in our case, we used the material called the Lucabond, which was an aluminum skin material with a polypropylene core. But this is what 1958 drawing that Bernie made.
Yeah, I think he revised it in 1960, but right, it was all
So an extrusion in this particular case would be a die would be made at the manufacturer that can push the slug of aluminum through that shape, and you can extrude these lengths. And then from there, they were cut to all the various angles and dimensions.
I'll just mention that this part faces the interior of the dome. And that part faces the outdoors. And the whole thing's roughly 2.5 inches, 2 3/4 inches thick. But of course, 4 feet, 4-ish feet long, various lengths. But
Did the caps snap in or did they screw in?
Jeremy can speak to that.
I know on a lot of the greenhouse, they snap in.
In the center section, that tongue
Yeah.
interlocks, and then through that center section, that extrusion is drilled, but not all the way through, and there's
Yeah.
a line through it that
Oh, very good.
actually
Yeah.
does go through it and it seals.
Yeah.
One of the things that I like about this slide is it shows that my dad was doing measurements to 1/1000th of an inch. You can see that with theirs, 1.700.
Wow.
Yeah, it's more tolerance than the machine shop can actually produce, but he's calculating. I guess there was a question in there.
So this is based on the geodesic principles. And I'm curious about the implementation of those principles. In terms of actually doing this particular scale, that particular house. I mean, there are other domes elsewhere, and that's one question. The other question is there some ownership of those, of the geodesic dome as a prototype?
Well, that's a couple of big questions that maybe we'll touch base on in different parts this evening, but I mean, one start on an answer is Bernie and knew Fuller well, and they had a lot of interaction together. Fuller was 29 years older, born in 1895, and Kirschenbaum was born in 1924. But there were a lot of innovation and invention in this dome that were separate from Fuller's foundational work. Bucky Fuller was a tremendous popularizer and had incredible charisma and really brought a lot of notoriety to the dome, but there were other contributors to the development of geodesics. I don't know if that helps.
We believe that this Stony Creek Dome is the first residential geodesic dome in the world. Right here in Stony Creek.
Bernie made sorry, go ahead, Jason.
I was just gonna say, because the opportunity for Jeremy to talk about the hub and the closure strip there. You can see it well in this picture.
Yeah, so that component there is the cast, sorry. That's one of the cast covers that covers, I don't know if we showed an actual hub yet, but.
Here's
something
this,
that
is
No,
that?
not yet.
Oh,
Well, that gives an example of how, that extrusion bar, which is the strut bar, which is the structure connecting to each one of those hub points. And then this is the capped piece of aluminum that captures whether it's glass or an opaque panel.
So the hub itself, is that also cast aluminum?
That's, the only parts that are cast are the hubs and the hub covers.
Are they cast the machine?
Sometimes they're the faces,
Face, yeah.
because they're sand cast.
Yeah, and then the extrusions fit on to.
Yeah, they fit in there.
So is there like a lip on the end that has a bolt hole in it and then it bolts into the hub?
The hub is a tongue that goes into the structure and structure slides over it.
And I'm gonna just add in, it's legendary about the calls with Alcoa and Bernie.
Yeah. No, that's a good point.
I believe there was a lot of phone calls back and forth with Alcoa on how to design and make these castings, which we are talking about calling them the hubs, where all these struts fit together. They're a critical element.
So Bernie, there's so many different things you can do with geodesics, and he tweaked the geometry in such a way so he had this, is about an 8-foot curtain wall of glass that was a level, so as a studio site, to have light 360. And we think it's a 5 frequency dome, correct?
It is a 5
So you're at below the midpoint. That would be like the middle point, correct? Like coming into the middle of the door.
Maybe that's about right, yeah.
So there was, I learned by trial on this all of these hub shapes, at least those are already in position, but it would have to be mapped out for sure.
There it is.
1968, so enjoying the fruits of his labor.
Yeah. And here's, whoops, oh yeah, that's me, and so that gives you a sense of the length of the project, because I got gray hair now.
And that's a jungle gym?
Actually, when I went through my father's papers, I found a stock certificate that he and Bucky had started a play dome company. And my father had stock in it, and that didn't take off, but it looks like I got to play with one.
Is that a glacier from the doorway, or is that the? I know one of the used to go, when I was growing up, used to come in the other side of the dome from the main, from the side downhill. Used to be the other side, and that door was blocked off with a piece of plywood or something.
Yeah. This is a great hand sketch that Bernie made on old yellow architectural trace, working out the relationship between triangles, the geodesic form, and making a final count of how many of each kind there are. There are a total of 9 different triangles, but 2 are mirrors of others, so maybe 7 different triangles plus the mirror image of 2 of those to make 9 unique triangles that comprise 275 more or less total facets. So there was a lot to work out here without any computational help from
No
modern
calculator.
age. Yeah. Yes.
Joseph, you want to tell us about your picture here?
Yeah, this is picture 001. I got a call from Susan. She said, can you take a walk over and look at the dome? And I walked up, and this path is the way this was the way to the dome. And these trees were literally, I don't know, 10 feet away from the dome. And I was looking at it going, all it's gonna take is one tree and no dome. And you can see some of the remnants of the, we were struggling with some vandalism that was occurring. And so the first step was to basically clear all the trees around it. And so, yes, I had to be the bad guy and say, we gotta cut these trees down. And I'm glad that we did, because since that we've had, what was it, Sandy and Irene. And as all of you know, there were some huge trees that blew down on the trail coming into the dome. And this was the inside, which was,
That's our.
Yeah, that was back in the day, yeah.
A lot of parties.
yeah, this was a little hard for me to take when I saw this. I was like, oh boy, how are we gonna fix this baby up?
Well, this was just shortly after what the time you're describing.
Yeah, and if I could, see that he's holding a triangle.
Yeah, I think you had that made up, Joseph. That's a mock-up, a test triangle of a double glazed glass unit, 2 layers with a gas interface, to see if we could do better than the single layer of glass from the early 60s. And so there's we're all in there. We're all there discussing and working on what's possible, what's not possible. But it turned out that to get double glazing in there would add a tremendous load to the exterior that would all transfer down to the edge of that cantilever.
So this is, I think this is around 2010, 11.
I think so, 10. I think this is 2010.
Oh,
and-
yeah, 2010.
And also it would increase the thickness of these panels from
Quarter inch.
a 1/4 inch out to something pretty chunky that would require re-engineering all those caps and sealant and caulk systems. It proved infeasible, so we did not go that route.
So then Ben came up with this.
Well, this was really kind of documentation and some addition, but this is part of the permitting set that we filed, a simplified version of the layout. And it's good to just glance out here because you can see, if I can borrow that pointer, you can see that this is looking down in plan now, right? This is a floor plan. You're free to walk around the entire perimeter. And this is the structure that holds the kitchen, closet, sleeping, study, bathroom. So this was part of Bernie's careful, considered conception. This is not my invention. We were restoring and drawing and rebirthing his architecture in there. And just to give you a glimpse of the building in section, this is looking sort of sideways. If you sliced it with a big cake knife and you look horizontally, there's that core in the middle. It holds all the functions with a big sleeping mezzanine, a queen bed and dressing area up top. And then the experience of this tremendous sphere from so many parts of the dome.
So this was the last time my dad saw the dome. He had heart failure, but we were able to rent a van that would hold his wheelchair, and he got to come and see that the work was getting done. One of my favorite quotes of his, it was right about the time this picture was taken. Some of these, you can see Jeremy and Joseph, and there was somebody else, and one of the 3 of them said to him, Mr. Kirschenbaum, you know, what advice do you have? We're working on this historic structure. And he said, build a cube.
No, that was to me, and he said he had so much difficulty getting things built, like he knew what he wanted to see, the end result, but he was working a little bit out of his element, with he was having things machined, I think in Bristol, and he was having fiberglass, and there's a picture of one of those shells coming in on a trailer. I mean, fiberglass was only being used in boats for a few years at that time already. So having these multidisciplinary kinds of fabrication happening and having it get done was the hardest challenge. That was one of the hardest challenges, but I think he really left such a clear footprint of what needed to be improved upon and where to pick up the baton and go with it.
Oh, yeah, panel replacement.
Jeremy is very familiar with every facet of every part of this dome. He cleaned it, he machined it, he went through every single piece of the dome.
If I may, this may be a good place to talk about those panels, the white ones, the product that we use.
Right, so the original panels were steel, enamelized steel with some kind of core. I think it was even like masonite or something.
It was
inside.
crazy.
And then there was some foam insulation. That what we ended up going with was something called a Luca bond, which is another term for the panel, but it's about 1/4 of an inch thick, and it's 2 skins of aluminum with a core that's polypropylene, and it's used often for like car dealerships. It's usually square panels that have gaps between them, and it's quite weather durable. We had to use this particular kind of coating because it was near the coastline, but it most closely replicated what Bernie would have probably used if he could have gotten something off the shelf, and
Looking good there, Jeremy.
And when I say Jeremy is intimate with every piece of the dome, there he is, cleaning.
you know, when I say these are projects of passion, I've been involved with others doing sculpture as well, and Sarah did give a shout out to her family. I mean, they really are the driving force behind this because they really color this whole story. And for me to, you know, suit up and do half of that project in a Tyvek suit, yeah, I was into it. I was into the material and the interface and seeing this get done, but it was a great pleasure to be doing this for Sue and for Bernie and for this group. And when you're doing something that's sculptural and that you can't put a value relative to how normal things are done, but it really it made the hard parts worth it for me.
This is the floor framing that was revealed when we tore off the yellowed crumbling epoxy original floor and the subfloor and had to get into all the hard mechanical work that these guys stewarded. This incredible web revealed itself of all these radial joists, kind of like a
Mouse skeleton.
yeah, like a 25-armed starfish.
And this structure here is the footprint. It's actually it's called the shoe. It's just slightly recessed from what those walls that would have been extruded upwards. But that's the shape that Bernie initially developed and Ben helped them refine for the final project.
Right, that's sort of the plan of all the little rooms in the middle.
So Joseph, speaking of passion projects, can you talk to us about this?
So, yeah, I was in charge of blasting. In Stony Creek, all of you heard about blasting. So one of the problems with the dome, it's built on the ledge. It has a very, very small crawl space, and there really wasn't any room to put in what we call the mechanicals, the equipment. And so what we decided to do, in consideration of what Bernie would have done, if it was feasible back in 1958, is we decided to go geothermal. So this is an underground mechanical room. And now when you go to the site, you can't, all you see is this piece is flush with the grade, that's covered. And inside this space is where all the equipment lives that does the heating and cooling. It's the hub for the water and the electricity. So we basically took all the MEPs and moved them into this space, freeing up the crawl space in the dome for the air handlers for the heating and cooling. And we very carefully, and does anyone remember Rick Hosley by any chance? Does that name ring a bell? He's probably one of the best blasting people. He's since passed away. And we actually blasted this section out first so we could build a mechanical room. Then we did the geothermal wells, and there were other photos that show all that jazz, but I chose not to bury you with all the mechanical stuff. And then we actually blasted all the way to the dome and up underneath it
Unbelievable.
without damaging the dome, which was just a remarkable effort. I couldn't be more pleased. And I did this on other projects in Stony Creek, so I've had a lot of experience with doing this. It's really technically possible, it just doesn't make sense that you can do it. So that's the story on the underground mechanical room, which I think is was an elegant solution to a problem. You know, if any of you been to Phil Johnson's glass house? For years, I saw all the pictures of the glass house and I had no idea there was another building behind it with all the mechanicals in it. So I was exceedingly pleased that our team came up with this concept and we buried it.
Well, how do you get it to fix it something then?
Can you go back?
From the top?
There's an aluminum door that's flush. And you just press your foot down and unlock it, and there's stairs that you go right down inside. It's like a bomb shelter.
Yeah.
And all the equipment's in there, it's nice and cozy. It's 54 degrees all the time.
Oh, go back to the fisheye for a moment.
Okay.
It's such a beautiful shot that Jeremy took.
That was in my back on the floor, looking up at the fisheye lens on the camera, and it just captured that whole, I believe, the whiteness is maybe, oh, that's, you're seeing the sky, you're seeing the trees, so that's all the glass curtain around, in the doors, and those are the pre-existing panels that were, the inside was a isocyanine insulation that had faded to like a red color, and somewhere in there, someone carved in home, dome suite, home.
So this is the perimeter of the dome, and these are the windows, the glass panels up to 8 feet high. Door, another door, and the apex, the top, if you look straight up.
There's 5 smaller triangle sets over the doors and 3 other spots.
Yes.
That's to aid in the structure to balance out the doors.
The pentagons, yeah.
If you look carefully, they start popping up everywhere.
Yeah.
There's one there, one there,
5
there.
You're looking at the pentagons or the
Yeah.
skylights?
Pentagons.
Ah, yes, right, there's 5 around the perimeter and 1 at the
Yeah.
top, and those. This might be something for Q&A, but those mark the vertices, the corners of an icosahedron. A 20-sided figure. That was the generator for this shape. Those little pentagonal, the centers of those pentagons are the corners of that platonic solid.
I ended up flattening that photograph and putting it into a CAD drawing, just so I could label each one of these struck bars.
That's 2 slides.
Oh, okay, good.
Yeah.
Early on in the process, there was a discussion about, honoring some solution for a stairwell, and I think in Bernie's early drawings, he wanted like a pneumatic tube or something,
Yeah.
right?
Yeah.
We worked with, glass engineer in, New York, Ben Source, that helped us with some of the influence of this stringer and the stair treads that we were going to produce, and it connects into the upper mezzanine. There's my map.
Yeah, for panel replacement, it's incredible, man, yeah.
And that picture is Jesse Good along with me. He was my partner on this project in the heavy lifting detail and everything with me. He's also a sculptor and you know, was willing to go to work to do something cool today.
And here's the lift that these was in such heavy use for you guys in panel replacement. I think actually in this photo, you were kind enough to give the architect a ride.
There's only so many places you could really access, so having something you go up and over from one location. There is with the new panels, new cabinets. The top, this top cowl is fiberglass, and then this top dome cap piece is aluminum. Originally housing a kind of active vent, and then those are the window skylights.
That slide and this slide are both kind of nice examples to say that this thing was just machined with such precision. And there, it's a one-off. They didn't we didn't wind up making 10,000 of them, you know, we made one. It's like designing one VW bug and building one. It's quite an undertaking. It's one thing if you're gonna build 2 million, but if you're gonna build one, it's quite an undertaking.
Sarah, before we move on, one of the keys to making this work is an earlier slide, we put in individual ductwork that all terminates right under the glass. And Jeremy made these custom grills so that we could get the what they call the air curtain that come up on the inside of the dome. So air conditioning is absolutely required, and the geothermal is working big time to do this. So we have a nice curtain of cooled air coming up throughout the full 360 degrees, except for the 2 doors. And then it also is the heat in the winter.
There were early days where, before we drove the strip, there was I was recording 124 degrees inside.
Yeah.
And
Oh, wow.
teens in the winter with them.
Yeah, a little cooker. Geo does it better.
So that was the final iteration of a stairwell to the
Let's come
mezzanine.
back to that stair.
And these cantilever again, cast aluminum steps. They were fun for me to make. I actually had to use a particular a rule that was made for shrinkage. So they were 24 inches, and I was casting these out of Tenzoid aluminum. They were going to shrink back to a certain size. So the wheeler was longer by 3/16 of an inch.
This was a marathon, this stair project, both for the designer and the fabricators.
But it was a real pleasure to do. It really is solid and it's elegant.
So this is a good time for you to bring in the building inspector.
Yeah.
Okay, for all of the architects in the room, sure, for all the architects in the room.
Close to the top here.
Right.
And
There it is. What they call the run and rise, the maximum rise is 9 inches. Our stair is 9 inches.
Oh, that's high.
And he was there with the ruler, checking it. And because the run turns, you see this little bump in the rail. This was just about gutted us as designer, contractor, architect. We did not want that bump in the rail. But when you do the arithmetic, when the stair starts to turn, the rise changes. And it's impossible mathematically to get it out. And I don't know, we probably spent
Oh, yeah, we wrestled.
200-300 hours trying to figure out how we could make this so we could get rid of the bump so that the railing would go. So we got a bump.
Well, it's a unique stair in that the top half is a spiral, but then it turns into a straight run stair. And so it's conforming and shaping itself to the existing architecture. in the way that Barney had envisioned the stair, even though his stair had some different details and materials to it.
Oh, I got one more thing back to the stair.
Yeah.
When you go up the stair, the last tread, you're allowed 6 feet 8 inches to the ceiling. It's 6 feet 8 inches. It's that exact. And so this stair is code compliant.
Well, it's a significant corner to put something that.
Yeah, it's tough.
It's large.
When my father knew that Ben was taking over, or not taking over, but it was functioning as an architect on this project. He took Ben by the shoulders and shook him and said, "You have to be me."
That was a powerful moment. It was a direct eyeball to eyeball.
Wow.
You can see the bed up top there.
You know, I know we're about to wrap, but on the slide before it, I just want to mention that beautiful form around the door, the fiberglass form. Jeremy, maybe you want to speak to them.
No,
Yeah, I know. It was tough.
yeah, so that was that was an unfinished detail by Bernie, but it was, kind of obvious to sort of follow the. Well, it doesn't follow the outside geometry either, but it was how we landed on resolving that interior so it felt finished, because before you were looking at these inner components of the fiberglass cavity.
Yeah.
And now you have, you know, an obvious like, easy access light switch right there, and then, we played around with iterations of how much glass to have in the door as well, and those doors that I've created out of in my shop out of a fiberglass and a composite urethane. And then I worked with a company in Newport, who works on racing boats, and they helped me with the interior shell structure to create the molds.
Okay, we're gonna wrap up here, so we still have a few minutes for questions. Here's the heroine of the whole project, my mom. And she comes and stays and really enjoys it and says it's exactly what Bernie wanted. So, really trying.
Oh, isn't that wonderful?
Look at that, wow.
Beautiful.
All right. I love this slide.
That's awesome.
Well, we tried to give sort of a collage of parts of this long story in these many chapters. And it's just a taste, but I hope it is a good taste and sort of spark some questions in your minds. I think we should probably close on our prepared remarks and see if there are any questions that we could kick around with you guys. Yeah.
So how did you seal each of those individual triangles to the frame? What keeps the water from getting in?
That is a huge question with all geodesic structures, right? Because it's so many linear feet of edge.
And what did you use? How
So
did you do
in one
that?
of those images, there was a cross section of the structure
Right.
tubing, which is the structure in of itself. And then there's that flat bar, if you can go back to that white one, Sarah, the outside finished panel. Those are kind of covered.
You want to cross that?
No, you can go to anything at this point, let's see. There,
Okay.
so. This is a very short piece of a strut bar tube that's connecting to my fist, which is a hub. And this is replicating one of the triangles. So this is your capture now on top of those strut bars. So you have a combination of butyl tape and silicone in there and then sealing rivets. So the panels have a certain amount of movement allowability for expansion and contraction, and the dome does shrink and expand in some manner. So but so far we've been watertight.
I mean, I guess another, to summarize that, there's this compression of these gas strips, as well as sealant,
Mhm.
a little belt and suspender situation, so that sealant on the outside.
And then the final striking of these joints, this was like an early mock-up I did of how we're gonna do it, but the final is a fillet joint, which is silicone, on that edge. So you see a fine black line on the.
Let's
Can you
take,
look back at one of the outside early images that shows the metal, right there? Talk about the hub part, right where it connects.
Yeah.
That's a really important detail.
So again, you have this, the glass panel, or whether it be an opaque panel is slightly, is going over a half inch over a component of the hub. And then that cast cap is going there, and as well are those flat caps. And there's underneath that is the sandwich of butyl tape and silicone, and then also a silicone seal along the edge.
let's take maybe two more questions, and then if people want to meet with us afterwards, I also have my email on that low table over there, if you'd like to email me anything. There's a few show and tell pieces, so.
Thank you.
Sarah, before we conclude, I'd like to do an ad for you, an advertisement. We met a couple years ago, on the same street. There's a wonderful, wonderful book. That's the backstory to your family, and I think it's called Outer Island. And Sarah gave me a couple copies, and then I went on Amazon and was able to get quite a few. If you like Stony Creek, or you like the, or you just happen to like Sarah and her family, it's great.
It's written by my grandfather Leonard Weil. I tweaked it a little bit and self-published it, yeah.
Sir.
So you partly answered a question that was plaguing me from the get-go when you said the word air curtain.
Oh,
So,
I was referring to the HVAC.
no, I got the basic concept, but I mean, my grandfather was a structural engineer and I grew up, hearing Bucky Fuller like it was the version of God. And then Fullerines came along in biology. It's been part of my life all along, but always there's been this tantalizing idea that you're talking about cheap, light, reproducible, mass marketing, whatever, and it never happened. So is that mostly about heating and cooling a structure like this? Is it that the use of space just didn't seem to work out the way people hoped it would? What, is there a fairly straightforward explanation for why this didn't play out?
I mean, I think that's one of the provocative questions that I've wrestled with a lot over this 12-year restoration process. Because the structure itself is very light, material efficient. But as you allude to, integrating other things into that structure, all the precision work of getting the panels to seal, integrating insulation into that assembly and mechanical systems does turn out to be take a tremendous amount of custom work and hours, not to mention furniture and all the other things in a right-angled world that have to now fit in here. I think the vision was, if this were a prototype and 1 million of them were made, you could in an alternate world imagine an actual low-cost offering, but you're so right, actually.
I think part of the answer, my dad says that when he first went to the first Buckminster Fuller lecture, he raised a point at the end of the lecture and said, isn't it over for single family housing? There's too many people on earth that have single family housing. So he was arguing with Butler before he really even worked with them.
I would say I think the big feat with the dome to overcome is the temperature control. So this project was honoring a vision that was started and completing this sculpture in a way that still, due to the influence of geothermal wells that Joseph put in there, and we can overcome the complexity of what's there, but would it be an easy grab as a purchase for anyone else to do? It wouldn't be the way to do it. You'd want to integrate better insulation and better thermal greatly from the exterior. I was to the Eden Domes in South England, and those things were great to grow tropical environments in a moderate to cool climate, easy to eat and eat. And they can use things like PVC as coatings, but the purity of this structure, it sort of supersedes the final execution of how it would really be used in the future.
Yeah, we're all tooled, the world is tooled towards right angle building and constructions ripples throughout culture, so once you start getting into these hexes and pence and triangles, it is, as you say, very, very complex.
So to speak to the bigger picture as a fabricator and builder. Everything about it is a dissimilar material. And this was a big challenge for Jeremy to be able to put the glass, the aluminum, the castings. And then the metal panels. All of them move at different rates, very, very complicated to make something like this. So trying to make it cost, to control the cost, it's not possible. But this was a prototype, and my hobby is racing, and everything that has been learned about the cars you drive today all was a derivative of making a prototype car. And this is a prototype structure that was really a sculpture. And to honor Bernie, he was way ahead of his time. So now we were able to bring in the geothermal. You can actually be in this dome during the 2 o'clock in the afternoon. The air conditioning is working hard, but it works.
Yeah.
And so that air curtain does come up, they return up in the mezzanine. I could go on and on here, but there's so many aspects of this that was experimental, and both Jeremy, Ben, and myself, we all worked together to try to realize what Bernie was trying to do.
So you could live there year round?
You could live there. Yeah.
It is an incredibly beautiful story.
Yeah.
So there was a before structure as well.
That picture that you saw, Bernie created this, he started in 58, and then he got to a point of, did you say 1975? When he, and then basically sat incomplete
I see,
until 2010,
I see.
when Susan decided that it was time to save it, and the rest of it, what we're sharing with you now, is what we did. It was a 10-year effort to do this.
And is the sleeping space one space upstairs for everyone?
There's a beautiful mezzanine with
Yeah.
a queen size bed and all glass railings all around with skylights.
Oh, my
There's two beds, smaller beds on the
Yeah.
first floor.
On the first floor.
Was there a question in the back corner?
Yeah, it was in conjunction with the expansion and contraction with the temperatures. You kind of alluded to what was addressed. How much was taken into account initially? You got aluminum, which expands and contracts differently than these panels. In the initial calculation, were they taken into account?
We used a greenhouse calculation, as if it was a greenhouse. And so we had a double air conditioning system with 2 air handlers, and so every other one.
Yeah, I mean initially in 1960.
Oh, I don't, Bernie actually experimented with a,
Heat exchanger,
what was it?
heat exchanger.
Heat pump. It was I'm blanking the name of it. Borg Warner from Ohio. It was like model number 1. And it had electric backup heat, that what they call second stage. And it's a good thing no one turned it on, because there'd be no dome, because the squirrels were putting all of their stuff in there. And 30 seconds to talk about that. Part of the build was to make this, all the wiring is in what's called armor jacketed cable. Because we had to make it squirrel proof, mouse proof, you name it. And so we did that, plus moving all the MEPs into the mechanical room underground solved some of that problem. So I hope I answered your question a little bit.
Incredible.
Is it tempered glass or is it?
Yes, it is tempered glass.
Did you replace all the glass?
All the glass was replaced.
How about the aluminum?
Jeremy replaced all of these strut bar covers.
The covers.
But the basic,
We hand polished every single strut bar.
Yeah, so the original structure remains and was remarkably solid and intact
Yeah.
and rigid, which is a characteristic of these geodesic structures that lock in place and have very little flex and quite a bit of stability. We want to take the temperature of the room, whether maybe it's time to give people a closure, and people could come up and ask questions individually, or are there burning questions that are still in play?
Can any of the panels be open? Can a window open?
No,
No. And is
just
that all?
two doors.
Be losing fun.
Otherwise, everything is sealed. It also has another piece of equipment called an ERV that circulates the air.
What's it like to clean all that glass?
So she's the clean, these two are the cleaners.
My wife and I.
How many? You got
88.
88 panels.
Well, it's 98 including the.
We're trying to figure out how to clean the top of it, because it needs it, with the way it is. Sure. And, I think we would have to rent one of those lifts, and get out there and do.
Drone.
Yeah.
Like drone, like a drone.
Yeah.
I'm so thankful for everybody coming out. Thank you, Pia, for.
Thank you.
keeping our house.